What if I told you that almost everything Hollywood has taught you about the word quantum is wrong? You've heard it before. Quantum means you can teleport. Quantum means you can be in two places at once. Quantum means magic, right? Wrong. We treat quantum physics like it's this mystical, spooky thing that no normal person can understand. We think it's a world where anything is possible and logic doesn't exist. But the truth? The truth is actually weirder than the movies. And the best part? You don't need a PhD to understand it. Today, we are killing the myths. We are going to take the most complicated science in the universe and break it down into plain English. By the end of this video, you'll know more about reality than 99% of the population. Let's debug the universe. Myth number 1. Quantum stuff only happens to tiny things. You've probably heard that quantum physics only applies to atoms, electrons, and things so small you can't see them. You think, well, I'm big, so this doesn't apply to me. Actually, it does. Quantum effects can happen right here in the human-sized world. Have you ever seen those futuristic trains that float above the tracks? That's not just magnetism. That is a massive, visible quantum effect called superconductivity. When you cool certain metals down, they stop acting like normal metal and start acting quantum. They push magnetic fields away so perfectly that they levitate heavy trains. That is a quantum effect you can touch, ride, and see with your own eyes. It's not just for the microscopic, it's for the macroscopic. Myth number 2, the one we all want to be true, quantum teleportation. We hear teleportation and we think, zap, I'm in Paris. Here is the heartbreaking reality. Quantum teleportation exists, but it doesn't move matter. It moves information. Think of it like this. Imagine you have a very complicated Lego castle in New York. Quantum teleportation isn't sending the plastic bricks to London instantly. It's sending the instruction manual to London so perfectly that they can build an exact copy of the castle there. But here's the catch. To teleport, the state of the first particle, the original one, usually has to be destroyed or changed. So if we use this on a human, we're not zapping you across the room. We're destroying you here and building a copy of you over there. Still want to step into that machine? I didn't think so. This leads us to the biggest brain twister of them all. Myth number 3, faster than light communication. You might have heard of entanglement. This is when two particles become linked. Einstein called it spooky action at a distance. If you measure one particle, you instantly know the status of its partner, even if it's on the other side of the galaxy. So people think, great, we can build a quantum phone and text Mars instantly. Sorry, but no. Imagine I have a pair of gloves. I put the left glove in a box and mail it to Mars. I keep the right glove here. The moment I open my box and see a right-hand glove, I instantly know the one on Mars is the left-hand glove. It happened faster than the speed of light. But did I send a message to Mars? No. I just know what they have. I can't use that glove to say hello. Entanglement is a bond, not a text message. Nothing, not even quantum information, breaks the speed limit of light. Myth number 4. In the quantum world, everything is random and uncertain. We hear about the uncertainty principle and think the quantum world is just total chaos, where nothing is defined. That's false. While some things are uncertain, like knowing exactly where a particle is and where it's going at the same time, other things are rock solid. An electron is always an electron. Its charge, fixed. Its spin, predictable. Its mass, constant. The quantum world isn't a messy blur. It's actually built on very strict, very precise rules. It's not magic. It's just a different kind of math. And finally, myth number 5. Einstein hated quantum mechanics. You've heard the quote, God does not play dice. People think Einstein was rejecting the science. He wasn't. Einstein actually accepted the math. He knew it worked. He just didn't think it was the whole story. He thought that the randomness we see in quantum physics was just because we were missing a piece of the puzzle, a hidden layer of reality. He wasn't denying the science, he was challenging it to be better. He wasn't a hater, he was a skeptic, and skepticism is how science grows. So, why does this matter? Because the universe isn't magic, it's something better, it's understandable. Quantum physics isn't about wizards and teleportation, it's about the building blocks of you, me, and everything we see. And the reality? It's far more beautiful than the myths.
Subscribe my channel for future videos. Thank you.